Hello everybody, welcome to engineering econometrics. We will again continue with nonlinear regression modeling and that to extension of dummy modeling, and the coverage will be specifically dummy dependent modeling. So, we have discussed various types of models and the applications relating to dummy modeling, where independent variable will be treated as a dummy, and specifically we have discussed couple of problems. We have analyzed the problems through subtiers and then connected with a particular case. Now, we like to see the other side of the game. How is the modeling behavior altogether when the dependent variable will be qualitative type. So, that means technically we like to address dummy dependent modeling. So, here we specifically have three types of models. So, the first one is the linear probability model, then otherwise it is called as a binary choice model. The second one is Logistic model, the third one is the probit models, right. So, we have three types of models: linear probability models, Logistic models and probit models. So, we like to discuss what are these situations we can apply these models and how is this models they are different to each others. So, that means we like to know the structural form of these models, that too with respect to BCM, Logit and probit. However, one typical common is the dependent variable, which is actually categorical or dummy type. That is the basic approach. Otherwise, the models are more or less same. So, we means technically the difference between these three models are with respect to various functional form only. So, the first one, that is the linear probability model, where it is a kind of linear structure and the other two forms are nonlinear structure. So, that is how it is called as linear probability model. And the second one, it follows with the logistic function. The third one, it follows with normal density function. So, we let us discuss the first one. Of course, it is not in the nonlinear form of models, but we should know the basic background behind this linear probability model. Though it is actually dependent variable qualitative, the independent variables may be some kind of different functional form, which we have already discussed in various way. Having dependent variable constant, independent variables, a particular independent variable or couple of independent variables may be in log format or the kind of square root format or exponential format. So, likewise we have a different kind of clustering, and that is how we can also discuss the linear probability model. Then we will move to Logistic models and probit models. So, let us see how is this particular structure. And so, technically linear probability is a very simple one, where the dependent variable will be categorical and all these models are connected with the probability in fact. And in the case of linear probability model, the look will be like this. So, where y equal to alpha plus beta x. So, the y will be represented as a 0 1, and most of the instances while using linear probability model. So, the y content will be either 0 or 1. So, that means actually like we have discussed gender. So, now the gender will be in the left hand side, that is the dependent variable, and then we have a independent variable which may be qualitative, may not be qualitative, not necessarily qualitative, which involves both quantitative and qualitative, but dependent variable will be qualitative, again varies between 0 to 1 only, but we know probability, and probability varies between 0 to 1. So, that means these are two extremes. If your problem involves 0 1 only, so that means like yes no, if yes equal to 1 and no equal to 0 or something like that, then by default the information behind y will be only 0 and 1, but it will not in between 0 and 1. If in case the information will be in between 0 and 1, then we can use the logit models and the probit model. So, that is how the two different options with us while using linear probability model and nonlinear probability models. So, in the case of linear probability models, so information will be between 0 and 1 only. So, in between contents are not there, but if no 0 no 1 and in between content, then in that case you can use either logit models or you can use probit model. So, now let us see how is this particular structure. So, this is the basic background behind this modeling, and then we will discuss various forms of linear probability models. So, typically like failure success, male female, then having house, not having house, having a bank account, having not bank account. So, these are the cases through which actually you apply linear probability models. For instance, let us say financial inclusion. So, one way to measure the financial inclusion is you may have a bank account, right. So, now we will have the survey, and then we will ask whether the guy has a bank account or not. If bank account, then this is 1, if not, then it is a 0. Now, if the dependent variable will be the financial inclusion, then obviously the problem will be what are the factors responsible for. Maybe income is a factor, employment is a factor. So, these are all on in the independent basket, but here dependent variable will be the financial inclusions, where the representation will be the the presence of bank account. If they have bank account, then this will be yes, and the numeric transformation will be 1, and if they have not, then the numeric transformation will be 0. So, as a result it will be only lying between 0 and 1, and that specifically in lines with probability model, where we are only two extremes 0 and 1. So, no in between 0 and 1. So, if it is in between 0 and 1, then we can use logit model and probit model. The same problems can be can be applied to logit model and can be applied to probit model, provided the sampling structure will be different. So, now let us say we have actually 20 different sample points. So, that means we are surveying 50 individuals or 10 individuals. So, with the intention that to know what are the factors responsible for the financial inclusion. So, you can start with 1, 2, 3 and 50, and every time you ask whether they have account or not account. So, like if yes 1, then if not 0. So, that is how the transformation is all about. So, that means in the first end you will get actually the information which involves only 0 1. So, by default the first choice is the linear probability model, but if you use something means if you are very much interested to use nonlinear regression modeling, and that too with the dummy involvement, and that too against dummy involvement with dependent variables. So, in that case the same problem can be. So, what we can do, you have to change the sampling structure. So, now instead of let us say 10 individual or 30 individuals, so now you have to select 30 different location altogether. Then within the 30 different location, every locations you may have a 30 different sample again. Then out of 30 different samples you check how many having account and how many having not account. So, having account if it is actually say 30 people having, all these 30 people having accounts, then by default the ratio will be 1. So, in that case this can be discarded simply, because we need to use the nonlinear probability model and that nonlinear regression modeling with qualitative dependent modeling or qualitative response regression modeling. So, here what we will do? So, in the second samples, so you can actually survey for 30 individuals again and then check how many having bank account. So, let us say 20 out of 30, 20 is having bank account. So, that means, so the financial inclusion quantification will be 20 by 30. So, that will not 0, that will not 1. So, then it will be in a that in between 0 and 1. So, that will be in a ratio format. So, if all the 30 samples are having no bank account, so then by default it will come down to 0, and if all are having bank account, it will come down to 1, and if few are having bank account, by default it will be lying in between 0 to 1. So, the locations where the information will be in between 0 to 1. So, that will be the counted samples for the Logistic model and the probit model. So, that is how same problems we can analyze, but the sample restructuring is required. So, means the way I have actually highlighted the issue, same problems, but your survey structure will be little bit restructure or redesign. Then once you have the samples, then as usual the processing will be similar. Okay, so, this is the basic idea behind the linear probability model, then Logistic model and probit models. Of course, we are interested to know how is this Logistic models and how is the probit models. Of course, the functional form will be different. In fact, the right hand side of the structure will be more or less same in the case of linear probability models, Logistic model and probit model, but what is the difference is the left hand side of the game. The first one is the simple linear one. So, where the data will be in between 0 and 1. The second one followed the logistic function. So, here the sample will be again 0 to in between 0 and 1, not 0, not 1, and the third one is the it follows with normal density functions. Again the sample or the data will be in between 0 and 1, no 0, no 1. So, that is the typical difference among these three models. So, where the first one is the linear one and the second and third one are the nonlinear one. Here is the typical classifications. So, that means this is the simple way of understanding. In between the complexity will be coming into the pictures if you use multinomial logistic functions or something kind of dummy qualitative response regression modeling with more number of dummies in the right hand side, that is the independent cluster. So, likewise you will find plenty of different kind of structures through which you can actually analyze the situation. In fact, the structure which you have discussed earlier. So, in the first hand there are three classifications. So, binary dependent, that is what we are actually discussing right now, then categorically dependent and then ordinally dependent. So, that is what actually the level of grading actually. So, binary dependent means again it is a 0 1 only, that is the binary numbers. Categorical means it is here the kind of classification will be more than 2. So, in the binary case it is the 2A classification, yes, no, 0 1, success, failure, like that, male, female. So, these are the kind of examples where binary dependent will work. And categorical dependent means like different category like Hindu, Muslim, other groups, Christians, like that, or say 3 types of educational levels like PhD, MTech, BTech, or 3 different forms of age groups of the peoples like let us say people having age of more than 40, then more than 30, more than 20. So, these are all various ways you can actually you can categorize. So, this can be one form of qualitative response modeling. Then ordinal dependent. So, here actually the same labels we have different kind of rating. For instance, good, better, best, like that, very goods, not so good. So, like that, different level of stars, typically a different scaling. Okay, we use Likert scale to do this kind of categorization, and sometimes some of the problems, engineering problems, will be such a way that the dependent variables having actually categorical in character or ordinary in character or binary in character. If it is binary in character, then we will come to this group. If it is categorical, you can come to this group, and if it is ordinal dependent, we can come to these groups. So, then again each basket we have a different forms of models. So, in the binary dependent, it may be quantitative independent or qualitative independent, but the dependent variable will be binary. It is qualitative, it is only in between 0 1. However, the game will be connected with either quantitative independent or qualitative independent, or it can be both quantitative independent and qualitative independent. So, it can go together also. So, again if it is a quantitative independent, so it may follow actually logistic regression again, and it can follow with also probability regression. Similarly, in the case of qualitative independent, so the form of the model will be log linear models, which we have already discussed. So, that means this actually brings different kind of nonlinear forms of regression modeling, and the entire structure of nonlinear regression modeling can be summarized here. So, now in the case of categorically dependent, again we have two different first and classifications. So, quantitative independent and qualitative independent, that is also equally true in the case of ordinally dependent. So, quantitative independent and qualitative independent. So, that means all these three categories we have first and classification, quantitative independent, qualitative independent, and then it may have that the mixture of two. So, that means binary dependent with the quantitative independent, or binary dependent with the qualitative independent, or binary dependent with the both quantitative independent and qualitative independent. So, this is the same structuring can be applied to categorical dependent, and again it will be applied to ordinary dependent, and in between you will find again various forms. So, again the way we have discussed in the binary dependent, in the case of categorical dependent. So, we have a quantitative independent, suppose there is no qualitative independent. So, in the case of quantitative independence, it can have two different forms. So, one form is called as a multinomial logistics, and the other form is called as a discriminatory analysis. Okay. So, discriminatory analysis means again, so it's kind of yes no type of situation. Then in the qualitative sides, it's like log linear models. So, that means technically if the dependent variable will be qualitative and the independent variable will be qualitative, then the structure of the model will be more or less same, that is the log linear models every case. This is also true here, this is also true here, again this is also true here, this is also true here. So, okay. So, this is one form, this is another form, this is another form. So, that is the kind of uniqueness among these three models. So, binary dependent, category dependent, ordinally dependent. However, in the case of quantitative independent, in the case of categorical dependent, you may have a multinomial logistic or discriminatory analysis, and in the case of binary dependent, we have a logistic regressions and probability regression. And again, in the case of actually ordinal dependent with quantitative independence, we have a ordinal logistic functions. So, that means the logistic function, one logistic functions will be common against for the kind of this is how the commonality will be find in these three categories, right. So, this is how the kind of classification we have in the case of a qualitative response regression modeling, where the common structure is dependent variable will be qualitative, and it differs with two different ways. First is the various functional forms, that to the simple linear format, and two different nonlinear formats, that to logit and probit. And against the dependent variables may have a three different forms, that is the binary dependent, categorical dependent, ordinal dependent, depending upon the kind of classification, different levels of classification. It means the starting with at least 2, then more than 2, and against little bit more flexible, more than 2, right. So, it is kind of the games. Then in between, the involvement of independent variables with the quantitative structure and qualitative structure, and both quantitative structure and qualitative structure. So, we have actually a pool of nonlinear regression modeling, and against the way I have cited already. So, it is actually very special kind of models, and it cannot be applied each and every engineering problem, depending upon the particular problems where the particular specification will meet, then you can just apply. After doing the structuring of all these model requirements, then the process of estimation will be more or less same like original or simple regression modeling. So, what is more important is that the kind of structuring. So, like we have actually, instead of x, we can use log x, instead of x we can go for square root of x, instead of x you can go for you can go for exponential of x. So, likewise various forms of and again instead of x we can follow the logistic pattern. So, that means technically we have actually a different kind of structuring to analyze this problem. And what is the requirement? The requirement is as per the problem structure and the kind of data structure, because ultimately the functional form of the types of model which like to use or to apply to estimate and then analyze the engineering problem exclusively depends on the problem structure and the data structure. Until unless you know the problem structure and data structure, you cannot just blindly use this model for the estimation, where the model outcome will be different and it will not pass through Blue theorem, and as a result diagnostic will be lost, and the kind of reliability will be lost. So, as a result, so what is the best is that, so you have to check the structure and check everything, then means everything means the data structure and the kind of types of models, the requirement, then we finally use, and again go for data transformation if it is necessary to process this model, because ultimately if you choose let us say probit regression model or logistic regression model, so it is an actually nonlinear format. So, you do the proper transformation that with respect to variables, and as a result the ultimate the transformation will go to the data, and then you will have a new form of the data which can be simply estimate as usual the ordinary regression analysis. So, that is the kind of structure which you have to follow. So, to estimate the process and to analyze the problem, and as per the particular engineering requirement and on the basis of the requirement of management decision. So, the kind of linear probability model is like this. So, simple model is like this. So, here the structure will be like this is what the y dependent variables, and this is the independent variable structure. Not necessarily the independent variable will be one, it can be many, and all are maybe quantitative in nature and few can be qualitative, and there is a high chance that all can be also categorical, and there is a high chance again both categorical and numeric. So, that is not the big deal. What is the big deal here? The y classification, that is the that means very special kind of problem this one. So, here sample structure must be 0 and 1, that is the only way you have to use the linear probability model. For examples, you know, lots of people staying outside from the home, and sometimes they have the own house and they may not have their own house. They used to stay in a rented house, and obviously you are interested to know what are the factors responsible for having own house, and what are the factors responsible against people staying in a rented house. So that means people having house or staying in own house or staying in a rented house, that is the two-way classification. If they are staying in, let us say, own house, then you can say that 1. If not, then you will put 0, whether it is a rented house or something else. So, the simple interpretation is whether people having own house or not, that is all. That is the question which you pose to the respondents, and then you like to find out, or you may have sufficient knowledge to know what are the factors through which you can actually explain whether the people having house or not having house, or people staying in own house or not staying in own house. So that means first questions you have to pose that whether you are staying in own house or not. Maybe people means there are so many factors. Maybe one of such factor is income. So if people have sufficient income or heavy income, and definitely they have their own house, because usually as a human being they are very much interested to stay in one house rather than staying in a rented house, because rented house means they will pay the money, right. So what they what they used to do, they try to have their own house, and for that you must have money, and there may be many ways you can have your own house, but one of the way is to you must have sufficient income. If your income is high, then you may be in a position to purchase the house, and as a result you can stay in your own house. That is the kind of an example which you can have. So now likewise there are couple of factors which are equally responsible for whether you have own house or staying in a rented house. So now until unless you know the particular structure, you cannot give a kind of an air statement. So so first you have this survey, then you go ahead with the estimation process. Now analyzing this kind of problem, by default whatever inquiry you will do, and whatever respondents you will capture. So obviously they may have the situation like some situation they have their own house, and some situation they have not their own house. Okay. Now if that is the case, then you can go ahead with the estimation process. Otherwise, if you are having survey and where all peoples are having one house, then this particular sample cannot be used for this particular model. So that is kind of biased kind of process, and again you are capturing a particular samples, and all are having actually all are staying in a rented house. That means they have not their own house. So this kind of sample also cannot be used for this kind of modeling. So this model can be used only when few samples will be having in such a way that they have their own house, and by default other samples they have not their own house. Then you can go ahead the estimation process and check whatever factors you have identified, whether they are significantly influencing the kind of case or not, right. That is the kind of structuring you will have, and in the case of linear probability models, right. So this is how the graphical look of the linear probability model. So the predicted line will be like this, and by default you will find two different groups. One group with say yes category, another group say no categories. This just means 0 y y pool with 0 coverage and y pool with 1 coverage. That is the kind of structuring. And the other form of the domain dependent modeling is the nonlinear structures, and that to the first nonlinear structure is the logistic regression model, where the regression that to dependent variable structuring will be like this. Okay. So here the regression structuring will be like this, okay, corresponding to linear probability models, where we have y equal to alpha plus beta x, or simply you can say p equal to alpha plus beta x, because y represents linear probability model means it will be only probability values, and that too only in extreme conditions, that too only in between 0 and 1. So, that is the linear probability structure, but here the format is log p by 1 minus p. So, but the right hand side is a constant alpha plus beta x, here also alpha plus beta x, that is the linear probability model. I am just comparing both the models and check the difference, how is that kind of scenario. So, here what is happening, this side is same, this side same, but the left hand side game is different. So, it is a simple p where the range will be only 0 and 1, but here again p, but p will be processed indifferently. So, we instead of direct p we are using a ratio, log of a ratio where p divided by 1 minus p. Usually in probability p represents probability of success, and by default q is the probability failure, which is the difference between 1 minus p, because total probability is exactly equal to 1. So, if p represents the success, then by default 1 minus p will be the failures. There is a high chance the success will be the 100%. In that case p equal to 1. If p equal to 1, then by default 1 minus p equal to 0. So, in that case, so 1 by 0, which is actually brings you infinite. But in other case, if the probability of success equal to 0, that means p equal to 0. So, the ratio between p by 1 minus p, 0 by 1 minus 0, so by default it will be equal to 0. So, that means ultimately depending upon the p, so you will find the ratio will be varying. So, one extreme will be 0, another extreme will be infinite. So, that means when p equal to 0, so that means in the linear probability models when we put p equal to 0, and again when you are putting p equal to 1. So, that means putting p equal to 0 and 1. So, you will find actually ratio will be say 0 to 1. So, like that we have to see the transformation. Now, what is happening? So, now corresponding to p value 0 and 1. So, your ratio here p by 1 minus p will also vary from 0 to infinity. So, that means while p varies from 0 to 1, then p by 1 minus p varying from 0 to infinite. But if any items or any data is having actually infinite quantification, then by default you cannot run these models. The software will not actually help you to calculate, even manually you cannot calculate, because you do not know the exact quantification. If you do not know the exact quantification, prediction cannot be possible. So, as a result, so the whole transformation will have actually bias sampling. As a result, you have to restructuring the particular means the entire process. So, now what is actually happening here, or what is the clear message here, that if the sample points are 0 1, then there is a problem here. In fact, if it is 0, there is no issue, but if it is 1, then there is a issue, but ultimately the total sampling will be exactly equal to 1. So, that is why, so if you like to use this ratio, so this the suggestive idea is that your p should not be 0, p should not be 1. So, it should be in between, right. For that you need actually group sampling rather than individual sampling. So, we need actually p represent probability of success. So, then check what is the percentage of success, that percentage of success will be the p, and by default that will be in between 0 and 1, not the 0, not the 1. If it is 0 and 1, then that means you can reject that sample for this particular logistic model. Okay. So, this is one way of understanding the structure about the logistic models and the kind of linear probability model. Likewise, the probability model is also similar kind of structure, where the right hand side of the game will be very much similar, that is the alpha equal to alpha plus beta, but here it follows the normal normal density functions. So, as a result, So, you just check how you can bring the transformation all together. Okay. So, how you can bring the transformation all together. So, ultimately, ultimately the p value will be again in between 0 and 1, and not exactly 0, not exactly 1. So, otherwise this can actually affect the entire process again. So, what is actually required here again? So, again if you will go for group sampling. So, that means technically for using logistic models or probit models, you should have a group sampling rather than individual sampling, and in the case of linear probability model, you simply use the individual sampling, where the dependent variable will be in between 0 and 1, but it will be the probability value, because all these three models are probabilistic models, and that too in the form of linear probability models and nonlinear types of models like logit model and probit models. So, now the beauty is that what are the situations you have to use, and again technically it is a special kind of models. It will be used in a special engineering kind of situations where we need to predict the requirement as per the decision making process is concerned. So, in the next class we will discuss these models again within suitable examples. In the meantime, we will stop here. Thank you very much. Have a nice day.